A very good morning. We are talking about independent sample t-test, and exercise 1 is something we have already done. The videos with you. Assignment was given for question 2 and question 3 of assignment 6. I suppose you have done it. And let's look at how we are going to solve these questions in this video today. Let's read question number 2 first. Two different methods were compared for helping people overcome snake phobia. It's also known as ophidiophobia. 20 people who suffered from excessive fear of snakes were randomly assigned to receive one of the two treatments: systematic desensitization, that is, small, progressive steps are made towards overcoming the snake phobia, or implosion therapy. The participant is overwhelmed or flooded with fear with the goal of overcoming it. So, after 3 weeks of treatment, the snake anxiety score for each participant was obtained using a measure of snake fear, with high scores representing greater fear of snakes. The data are in file exercise 6.2.sav. The variables in the file are named therapy and snake fear. For therapy, 1 is systematic desensitization and 2 implosion, that's there. So we have to open the SPSS file and then start, you can say, looking at the data. Before that, let's look at the questions we have. We have to state the null and alternate hypothesis. That's A part. B part, we have to state the research question for the data. Test for assumption of equal variances. Do data suggest unequal variances between the group? 3. Is there a significant difference in the reported anxiety between the groups at alpha is equal to 0.05? What is the effect size? Is it small, medium, or large? So that we have to see. And finally, we have to put the result, you can say, in the right form. So we have to write the result. Now, coming to the question once again, before we start talking about the answers, there's a question on two different methods being applied or therapies being applied to overcome snake phobia. And we have got 20 people who have been, you can say, uh, suffering from excessive fear of snakes and randomly assigned one of the two treatments. One is systematic desensitization, and second method we have used is implosion therapy. Okay, and the data is given in the SPSS file, where systematic desensitization is 1 and implosion is 2 for snake fear. And that you can say the anxiety level, that's the second variable we have got, is there in scale form. So that's given to us. Now we have to state null and alternate hypothesis, and I'm simply speaking them right now. Null hypothesis: there is no significant difference in the anxiety level of participant who have been either treated using systematic desensitization or implosion therapy. Alternate hypothesis: there is significant difference between participants who have been suffering of snake phobia being given either systematic desensitization therapy or implosion therapy. Now coming to B part, we are talking about the research question. The research question that needs to be answered here is there a difference in the anxiety level of participants after being treated using either systematic desensitization therapy or implosion therapy? So part A and part B of this question we've answered. Coming to part C, if you look here, C, D, E, and F, all these questions can be only answered when we have done the analysis part. So let's move to the SPSS file, and I'll be having a new share for you. We are just moving to the SPSS file. Okay, and this is the file is open. So we have got, you can say, the data view and the variable view. So this is the data here for you. Therapy is there. So we have got therapy 1 and therapy 2, and this is a snake fear level. So snake fear level is there. and some value is assigned to it. Now, if you look at the variable view, we have the variable, and in the variables we have got, you can say, the therapy named. So therapy is therapy employed for helping, you can say, people overcome snake phobia, that is known as ophodophobia. So we have values assigned for that. So we have one, which is systematic desensitization. Two is employism, and this is basically a nominal scale because we have got category of, you can say, therapies that is being, you can say, taken up for the people who have got high snake fear. Now coming to snake fear as a variable, what's the level of snake anxiety score for each participant after they have gone for 3 weeks of the therapy? Either therapy one, that is sensitization, and second is employism. So how they have fared, and this is basically given in scale form. So we have a data with us. So this is the data with us, and now we are moving to, you can say, we are just moving to analysis part, and talking about the analysis part. So what we'll do is I'll just come to the analysis file now. So we are moving to analyze. So here I'll be going first to compare means. Then I'll go to, you can say, independent sample t-test. Click on that. And then we have this table coming up. Snake anxiety is our independent variable on which you can say how people, you can say, look at, sorry, therapy employed basically is our independent variable, and this is basically specified in two things. One is, you can say, sensitization, second is employism. This is what we are mentioning here, the type of therapy that is being given, this being independent variable. Now we have the dependent variable, that is how the people, you can say, are losing, you can say, are getting, you can say, reduction in the fear level, or the snake anxiety is, you can say, getting less for these people who have been treated through these two, you can say, therapies. So the test variable is there, and I'm putting up the test variable here. So that's done. And we all know that the alpha value which we are going is at 0.05, that is 95 confidence interval level, which is already mentioned. It is by default, so we'll not touch here. And then we'll simply, you can say, click on this button of OK. The moment we do, we are getting, you can say, the output file. I'm taking you to the output file, and here we are with the output file. We have got the answer here. So we have got systematic desensitization as one variable. We have 10 respondents here, and the mean, you can say, phobia or fear level these people are having is 47.1 with a standard deviation of 6.8. Whereas if you look at, you can say, employism, here again 10 participants are there. The mean score is 59.3 and standard deviation is 11.64. So that's another thing we are having here. Now coming, you can say, to the main question here, we are now to answer C part of the question, which is talking that, okay, fine, are there significant differences in the variance of the two population? Now, if you look at the standard deviation here, it does appear that the variance is there. 6.8, you can say, standard deviation for the systematic desensitization, and 11.64 for employism. That is the, you can say, standard deviation. We know variance is square of standard deviation, that we always know. Now coming, you can say, to the Levin's test of equality of variances, here significance is 1.147. It is not 0.05 or less than that. It is much higher to it, and therefore we are not accepting the fact that there is much difference in the variances of the two population, uh, and therefore you can say we'll be just studying row 1. So row 1 is our answer which we'll be considering. So that was point 1, where we need to answer, you can say, the things. Now coming to the actual, you can say, actual to the, you can say, that whether we are going to accept the null hypothesis or the altered hypothesis. Here if you look at the t-value, the t-value comes to 2.859. I will not be considering this minus symbol here, and you know the answer. This is something we have discussed previously also. Since systematic desensitization is a lower value, which is numerator, and employism, you can say, therapy, which is denominator, has got a higher value, 59.3. the symbol is minus. Had we named, you can say, implosion as 1 and systematic decentralization as 2, the things would have been reversed. First, we would have been getting the data of implosion, which would have been 59, and then systematic decentralization, where the data would be 47 something. And therefore, in that case, the value of t would have been 2.859 and not minus 2.859. So just remember that never consider t value as negative. It's always a neutral one. So my value here is 2.859. Degree of freedom is 18. And you know why it is 18? It is 18 because we have got 20 participants. So n is 20 and k means number of columns. We have got two, you can say, categories of, you can say, therapies here. One is systematic desensitization, second is implosion. So k is 2. So degree of freedom, df is equal to n minus k is equal to 20 minus k, 20 minus 2 is equal to 18. That's there. And the significance we are getting is exactly 99%. It is 0.01. So the confidence interval level is 99%, or you can say the significance is 0.01. In this case, you can say since the p-value or significance value is less than 0.05, we are accepting the alternate hypothesis. That's there. Now, we are coming to the E part of the question where we have to answer about the effect size. Now, if you go back to the notes and recollect the formula over there, in case of independent sample t-test, the effect size D, small d I'm saying, small d is equal to t into under root of n1 plus n2 upon n1 into n2. So we know the formula. It is simply, you can say, 2.859 multiplied by under root of, within brackets, 10 plus 10, that is 20, upon 10 into 10, that is 100. So that is the thing here. And when we solve this particular thing, the answer I'm getting is 1.27 or 1.28. So 1.28 is my D value. So that's the value of D I'm getting now. So effect size, we all know, if D is equal to 0.2, effect size is small. If D is near 0.5, the effect size is supposed to be average or medium. And if D value is 0.8 or more, it is supposed to be large. Here the value of effect size comes to 1.28 or 1.27, whatever the actual value you are getting, please mention that only. So that is saying that the effect size in this case, when we are talking about two different types of therapies, systematic desensitization and implosion as a means to cure people's, you can say, phobia towards snake, and there the effect size between the two, you can say, methods applied is quite large. It's quite large at 1.28. Done. So that's there. Now coming to the last part of this question here, we are talking of the F part of the question where we have to write the actual answer. So how we are going to write the answer? Please look at how I'm speaking. Systematic desensitization, within brackets, M is equal to 47.1, comma, SD is equal to 6.82, bracket close, is more effective means of reducing snake phobia as compared to implosion therapy, within brackets, M is equal to 59.3, comma, SD is equal to 11.64, bracket close, comma, small t, within brackets, 1.8 is equal to 2.859, comma, small p is less than 0.05, comma, small d is equal to 1.28. So that's the answer we have got for this particular part. And let's look now at question number 3. And now coming to question number 3, a researcher wanted to investigate whether there was a difference in satisfaction with nursing homes between residents who had access to a community pet and those who did not. Satisfaction was measured on a 5 to 25 scale, with high scores indicating greater satisfaction. Nursing homes residents participated in the study, with 30 residents participating from a home with a pet and 30 participating from a home without a pet. The satisfaction score for residents are located in file xis 6.3.sav. In the variables in the files are named group and satisfaction. For group, 1 is pet and 2 is no pet. Open the SPSS file and perform the appropriate analysis to answer the questions below. So here again, we have to do the same thing. We have to state the null and alternate hypothesis, state a research question for the data, test for the assumption of equality of variances, and look at the significant difference in satisfaction between nursing homes with people who have pet and who do not have at 0.05. That's what the alpha is. And find out the effect size, and finally you can say write the result of the study. So these are the questions we have got. So again, just trying to have an understanding of the question. So a researcher is investigating whether there's a difference in satisfaction with nursing homes between residents who had access to community pets and those who did not. And this satisfaction is being measured on a 5 to 25 scale, with higher score indicating greater satisfaction. We have, you can say, 60 nursing, you can say, home residents who are participating in the study, 30 having, you can say, pets at home, and 30 you can say didn't have any pet at home. So that's there, the data is already given to us. So we know that the variables are named as group and satisfaction. So group means you're having a pet or you're not having a pet. 1 means having a pet, 2 means no pet. And then maybe satisfaction is in the scale form where the values are between 5 to 25. Higher values meaning that you are more satisfied. So that being the question, coming to the hypothesis, talking about null and alternate hypothesis. Null hypothesis. There is no significant difference in the satisfaction level of residents having pet or not having pet. Alternate hypothesis. There is a significant difference in the satisfaction of the residents having pet or not having pet. Now coming to B part, research question for the data. Is there a difference in the satisfaction level of residents having pet or not having pet? So that's the question. Now answering question, you can say 3 with, you can say with C, D, E, and F part, we need to, you can say, move to the, you can say SPSS file, and I'm moving straight to the SPSS file for you all. So this is the file we are sharing, and so I'm trying to, you can say, come with the things. So this is data given to us. So this data is, you can say, the group is there, 1 is there, 30 you can say respondents where you can say having pet, and another 30 is having, you can say, no pets. And then you can say the satisfaction level is given in a scale of 5 to 25. So that's given to us. Let's look at the variable view. We have got group as well as variable, where the values are, you can say, 1 for pet, 2 for no pet, and it is basically a nominal scale. Satisfaction, how satisfied they are. Well, fine, they are the values with higher values indicating that, okay, fine, you are more satisfied. The values fluctuating between 5 to 25. So that's there, it's a scale form. So that being the, you can say, the value and the data. And now coming to, you can say, the analyze part, we are analyzing, click on analyze, compare means, and then move straight to independent sample t-test. So there we do group, we are making a group variable, we're defining group as 1 and 2. 1 we know people having, you can say, pets. 2 means people not having pets. We continue. Satisfaction is a test variable. Options, I'm just clicking because just to show you that, okay, fine, the confidence interval percentage is 95, meaning a significance of 0.05. So that's there, we are looking at that. Continue, I'll simply click on OK, and we are now getting the answer in the you can say output file. I'm sharing the output file for you now. So that's there, and here we are. So this is the answer. which we have got, you can say, satisfaction with people, you can say, having pet or no pet. Both, you can say, we have got 30 respondents in each of the cases, the mean being 16.67 and 17.73, with standard deviation of 3.98 something and 3.64 something for both of them respectively. So that's the data we have got. Now coming to C part of the question, which was talking about that are there any difference in the variances of the two population. Now, if you look at, you can say the Levin's test is actually, you can say, answering that question. So the value of significance comes to, you can say, 0.625, and the value of, you can say, Levin's test F is equal to 0.241. So if you actually look at the value, it comes to, you can say, P value comes to 0.625, and had this value been, you can say, 0.05 or less than that, we would have accepted that there is a difference in the population as far as variances are concerned, but not in this case because the value is above, much above 0.05. So we'll be just going for row 1 right now. So row 1 we go when variances differences are not there. If variance differences are there, where this significance happens to be 0.05 or less than that, we go for row 2. So we are not going for row 2, we are going for row 1, and the reason you all know. Now coming to, you can say, value of t value is 1.081. Remember, I'm saying it is 1.081. I'm not saying minus. And the reason behind is that if you look at, you can say, the two values we have got, or the means we have got for pet and no pet, the value for pet is 16 point something and 17 point something for, you can say, no pet. So since there is no difference here, or very less of difference here, but the numerator happens to be smaller as compared to, you can say, what do you call it, to denominator, therefore the value is minus. Had we, you can say, mentioned no pet as 1 and pet as 2, the value above would have been higher, the lower would have been less. Sorry, the above would have been, you can say, higher, and maybe the second one would have been lower. So this means, you can say, then this value of t would not have been, you can say, negative, would have been just, you can say, 1.081. So we'll just write the value of t as 1.081 when we are mentioning the answer, and not, you can say, as negative. This is something I've repeated in every, you can say, exercise I've done. So we do understand why we are writing it in negative or positive, and maybe you can say we are always taking it as positive. Now degree of freedom is, in this case, is equal to n minus k. We have got 60 values, n is 60, k is number of columns. We have got two, you can say, groups here, pet and no pet. So k is 2. So this means 60 minus 2 is 58. This is what the degree of freedom is. Significance comes to, you can say, 0.284, which is, you can say, quite higher as compared to the actual required or desired p-value of a small p should be, you can say, is equal to or less than equal to 0.05. So that's not coming that way, and therefore we are accepting the null hypothesis. So there is no significant difference between uh, the satisfaction level of residents either having a pet or not having a pet. So that's what the answer is. So we have answered, you can say, the D part also. Now coming to the next question, we are talking about the effect size. If this is there, and what is the effect size? Is it small? Is it medium? Is it large? That we are looking at. And the answer here is that, okay, fine. D, that is talking about effect size. Effect size is equal to small d, and small d is equal to the t value multiplied by under root of, with numerator we have got n1 plus n2, denominator we have got n1 multiplied by n2. So I have just calculated the value. The value is coming to 0.28. If I'm very correct on this, it's coming to 0.28, almost 0.28. So you can look at the answer from there. And if you look at the value from there, so D value comes to, you can say, 0.28, which is near to, you can say, 0.20, which means the effect size is small. So this is something you can refer to notes on this. So, you know, if it's near, you can say 0.2. It's more of, you can say, small effect size. So our answer is 0.28, which means you can say the effect size is small. So that's there. And last and the final EF part of the question 3 I'm talking of, we have to, you can say, just write the result now. Um, we can write the answer this way. Satisfaction level of residents with pet within brackets M is equal to 16.67, comma SD is equal to 3.98, bracket close, is similar to residents having no pet within brackets M is equal to 17.73, comma SD is equal to 3.64, bracket close, comma T, small t I mean, within brackets 58 is equal to 1.081, comma D is equal to 0.28. So that's the actual and complete answer for you. And this way we have solved both these questions, question 2 and question 3. I hope this topic of one sample, you can say, sorry, independent sample t-test have been good learning for you all. So thank you. Next week we'll again talk on some other topic of compared means or means only. So thank you for the day. Thank you.